So you're staring down the barrel of the AMPP CIP Level 1 exam. I get it. 120 questions, 3 hours, it could feel pretty overwhelming. But what if I told you there's a smarter way to study? What if you could zero in on the exact topics that will get you the most points? Well, that's exactly what we're about to do. Think of this as your strategic roadmap to focusing your energy right where it counts.
Here's our game plan. First, we're going to crack open the exam blueprint to find the high-value targets. Then we'll dive deep into the heaviest-hitting domains. After that, we'll get hands-on with the key calculations and learn how to spot common defects. We'll also cover your core responsibilities as an inspector, and finally, we'll lock it all in with a quick rapid-fire review. Ready? Let's get into it.
Okay, here's the absolute most important thing you need to grasp right now. Not all topics on this exam are created equal. Seriously, the key to passing isn't about knowing a little bit of everything. It's about knowing a lot about the things that count the most. So we're going to use the official exam blueprint to point our study time like a laser for maximum impact.
Now take a look at this. This is where it all becomes crystal clear. Surface prep. That's a solid 20% of your total score. Encodings and inspection, another 20%. You do the math, that's a whopping 40% of the entire exam packed into just 2 areas. So if you want to pass, this is where you have to be absolutely rock solid. So now that we know where the heavyweights are, it's time to step into the ring. Let's dive deep and really get to know these 2 crucial domains, surface prep and coatings. You know, this simple quote is, well, it's everything. Never paint a dirty surface. It's the golden rule, the bedrock of our entire industry, and it's really the heart of what Domain 5 is all about. Why? Because if that surface isn't prepped correctly, the most advanced, most expensive coating on the planet is guaranteed to fail. It's that simple. Everything starts right here.
So, what does that actually mean for the exam? You've got to know these key tasks inside and out. First, SSPC SP1 solvent cleaning. It always comes before you start blasting, always. You'll for sure get questions on measuring surface profile with replica tape. You also have to be on the lookout for the invisible enemies, right? The non-visible contaminants like soluble salts. And finally, you've got to be able to spot fabrication defects on welds using the NACE SP0178 replica, which is basically a physical cheat sheet of what good and bad welds look like.
Okay, let's switch gears to our other heavyweight champion, Domain 6 coatings. One of the biggest concepts you have to nail down is the difference between thermoset and thermoplastic coatings. It really all comes down to how they cure. Think of it this way. Thermoset coatings, like an epoxy, have a chemical reaction. They get hard and they stay hard. It's a one-way street. Thermoplastics, like vinyls, just dry. The solvent evaporates. If you heat them up later, they'll soften right back up. You need to know this difference. Now, switching over to the inspection process domain, there's one term you absolutely cannot forget: hold point. So what is it? A hold point is a line in the sand drawn in the inspection and test plan. It literally means all work comes to a screeching halt. No ifs, ands, or buts. Nothing moves forward until you, the inspector, physically sign off that the work meets the spec. It's the ultimate quality control gate. This might sound like just a nice little phrase, but it's actually a core philosophy you'll be tested on. Coating inspection does not cost, it pays. And here's why that matters. It's the entire economic reason your job exists. A couple of hours of your time carefully documenting a problem today can prevent a catastrophic multi-million-dollar failure years from now. You are literally the insurance policy for that asset's entire life cycle.
All right, let's roll up our sleeves and get practical. This next part is all about the hands-on skills. We're talking about the must-know math and the lineup of usual suspects, the coating defects you need to be able to spot from a mile away.
I want you to memorize this slide. Burn it into your memory. I can almost promise you that you'll have to use this formula on the exam. DFT equals WFT times the percent volume solids. So your final dry film thickness is just the wet film thickness you measure, multiplied by the percentage of solids in the paint. This is the magic formula that connects what goes on wet to what you measure dry.
Let's make it real quick. How does this actually work? Say you take your gauge and measure a wet film thickness of 160 microns. You grab the product datasheet for the paint and see it's 40% solids. Now here's the key step. You've got to convert that percentage to a decimal, so 40% becomes 0.40. Then just multiply. 160 times 0.40, and you get a final dry film thickness of 64 microns. See? It's simple, but you have to know those steps.
Next up, you're a detective now, and you need to know your crime scene. The exam won't just ask you to see a defect, it'll ask you what caused it. For instance,
You see here, if you've got fish eyes or sissing, that's screaming oil or silicone contamination on the surface. And sagging, that's a classic telltale sign that the coating was slapped on way too thick. Knowing the what and the why is absolutely key.
Okay, we have covered a ton of the technical stuff. But, being an inspector is way more than just using gauges and running calculations. This part is about your professional duties, the lines you can't cross, the records you have to keep, and frankly, the ethical backbone of the entire job. This right here, this is one of the most critical distinctions you will ever have to make on a job site, and you bet it's on the exam. Look at these two columns. The contractor performs the work, they direct their crew. Your job? You observe. You report. You verify that what they did complies with the spec. You are not the foreman. You document what you see, objectively. You never, ever, ever tell the contractor's team how to do their job. So how do you report? Through your documentation. This is basically Domain 8 in a nutshell. Your logbook and your daily reports, they have to be 4 things: timely, accurate, concise, and factual. And I can't stress this enough, no personal opinions. You don't write, "The painter looked tired and did a sloppy job." You write, "Observed sagging on the north-facing wall, DFT readings exceeded spec by 2 mils." Just the facts. Your documentation is a legal record. Treat it that way.
And now for the really tough stuff. The exam is going to put you in some tricky spots with ethical scenarios just like this one. Your boss walks up and says, "Hey, listen, just let that one slide, okay? We're way behind schedule." So what do? This is where your integrity is truly put to the test. Here it is. This is the only right answer, according to the AMPP Code of Conduct. Your number one priority, always, is public safety. So you calmly and professionally document the request from your boss right there in your logbook. You report the non-compliance exactly as the spec requires you to, and you never, ever falsify a record. Your certification, not to mention the public safety, is worth way more than any project's timeline.
Okay, we are in the home stretch now. Let's do a rapid fire round. These are the facts you just need to drill into your brain and memorize. No deep theory here, just pure, simple recall. Let's knock it out.
First up, the corrosion cell. You need 4 things, and only 4 things: an anode, a cathode, an electrolyte, and a metallic pathway. Take away any one of those, and corrosion grinds to a halt. Just memorize those 4.
Safety data sheets, you have to know these sections by their number. Section 2 is hazards. Section 8 is PPE. Section 11 is toxicology. They will ask you specifically which section contains what. Don't get caught out. And remember this hierarchy, this pecking order. If the manufacturer's product data sheet says one thing, but the job specification says another, which one wins? It's always the same answer. The job specification is king. It's the final word, the law of the land for that project. End of story.
So there you have it. We've broken it all down. You now have a strategic map to go out and crush the CIP exam. You know what to study. But the real question, the one that matters long after you've passed the test, is this: how are you going to apply this focus every single day on the job to ensure the safety and integrity of the bridges, tanks, and pipelines you're responsible for? That's the real job.